quickly. Mr. Three connectives like negation and or single implication, and we also discussed double implication. So basically, double implication is what? Okay, prior to that, the single implication, how it can be pronounced? It is also called as P implies Q, or it is also called as P is sufficient for Q, or you can say Q is necessary for P, Q is consequence of P, and something like that. So this is what we already discussed. Now let us go ahead with respect to the bidirectional implication. It is also called as biconditional statement, biconditional connective. So basically, what is this P bidirectional Q is nothing but P if and only Q. And if it is only single implication, it is if P then Q. This is P if and if P if and only if Q. That means if P then Q, and if Q then both. So there is a strictness from antecedent to consequence as well as from consequence to antecedent. In the earlier case, there is a strictness from antecedent to consequence only. There is no strictness from consequence to antecedent. Means what? When we do have antecedent true and consequence is false, this P implies Q is false. But if we have consequence true and antecedent false, at times it is not false. There is no strictness in this, but there is a strictness in this. So we'll see this now. So we already discussed what is P implies Q. We given these truth values. What is P implies Q? What is Q implies P? And then it is basically AND operation of these two. Let me just copy this. Okay. So if you take the AND operation, the result is true, result is false, result is true, result is false. Okay. So what does it indicate? When the antecedent is true, sorry, here, this is P implies Q and Q implies P. When the antecedent is true and consequence is true, then and then only is P implies Q and Q implies P is true. Okay. Similarly, if the antecedent is false and consequence is false, then and then only P implies Q and Q implies P, this bidirectional condition is true. Why? Because we are saying now here, if P implies Q and Q implies P. So P implies Q is true in this condition, P implies Q is true in this condition, P implies Q is true in this condition. Similarly, Q implies P is true in this condition, Q implies P is true for this condition, but for which P implies Q is not true, therefore it is false. So there are only two ways this bidirectional condition is true. If both the antecedent consequences are true, bidirectional, or double implication, biconditional or double implication is true. Both are false. Sorry, here. If both are false, that is, and consequence, then it is true. So if you evaluate this truth table for P bidirectional Q, so P bidirectional Q means what? P and Q and Q and Q. Similarly, Q bidirectional Q means what? Q and P and P and Q. So definitely you will get somebody we are, but it is basically computed either Q bidirectional Q or P bidirectional Q is basically this. And you can see here they obey commutative law property. So single implication do not obey commutative property, but bidirectional condition obeys commutative. All right. Now how we can interpret this? How it is just like here, P is sufficient for Q means what? Given P is true, then Q has to be true. If we want P and Q has to be true, then if P is true, it is a sufficient condition for Q has to be true. Similarly, Q is necessary for P. So what we are discussing here, that P is sufficient for Q and Q is necessary for P. Means what? Suppose what is the another way I can say this? Uh, Let us say if you pass an exam, then you clear the course. So to clear the course, you need to pass the exam. So to pass the exam is sufficient for clearing the course. That is the way you are understanding this. And what is Q is necessary for Q? To clear the course, you need to pass the Q is necessary for P. Means what? Clearing the course is necessary condition for passing the exam. That's it. So don't get confused. We'll have many examples that we'll see in a short span of time. What is the point that we are discussing here? That earlier example, if I will give you a gift, you see what is the statement P implies Q. If I give you gift, you need to pass an exam. So if I give you a gift, it is true, and you have not passed an exam, so this is not accepted. Similarly, if you pass an examination and I do not, just wait for a minute. So what I am saying now, if P then Q and if Q then P. That means if you pass an exam, I will give. If you pass an exam, P. Sorry about that. If you pass an exam, I will give a gift. You have passed exam and I am not giving you a gift. Not it's a violation of the promise. Okay. Similarly, uh, that means what? If you pass an exam and I am giving you a gift, valid. If you pass an exam and I am not giving you a gift, not. Yeah, it is violation of the property as well as now going ahead. If you do not pass exam and I am not giving you a gift, valid. If you do not pass an exam and I am giving you a gift in a single implication, I am not violating any promise. But now if I go for double implication, means what? If you pass an exam, then I will give you a gift. This is one way. What is another way? If I give you a gift, then you would have passed the exam. Both way there is a confirmation going from antecedent to consequence as well as from consequence to antecedent. So if you pass an exam and I am giving you a gift, valid. If you pass an exam and I am not giving you a gift, so violation. So coming here, it is not accepted. If you do not pass an exam and I am not giving you a gift, that is true. If you have not passed an exam, I am giving you a gift, not valid as per the bidirectional condition. I give you, then you could have, but it is not false at present. Therefore, false. And that why that is very we say is necessary and sufficient condition for Q. It is necessary as well as sufficient. Many P is necessary and sufficient condition for Q. Meaning of necessary means what? If Q needs to be true, P has to be true. That is the meaning of necessary. Okay? It doesn't mean that it is only P need to be true. If there are some other variables need to be also true, then that will be also necessary condition. In this bidirectional condition, it is necessary and sufficient. Sufficient means what? If P is true, this is sufficient to claim that Q is also true. Sufficient means giving this one fact is true, that is sufficient. No need of any other facts for proving the Q is true. Then we say it is sufficient condition. Necessary means what? If P is true, Q will be true, but in that necessary, sufficient word is not there. If you, it is just like, what is the another example I can give you? Wait, I can understand. Okay. Let us take a medical example. If you visit the doctor and you say that I have a fever from last 24 hours. Now, this is the symptom that you are having a fever. Now, what is the root cause? Why you may have a fever? So, you may have a fever because of maybe coronavirus, because of maybe dengue, typhoid. So, typhoid is a disease which is necessary to have a high temperature of your body. But need not be it is the reason because of that this temperature is high. Whatever the source you are given, if that source is there, the temperature is there. There is an association, but it is not guaranteed that because of that only it is having the temperature. Sufficient means what? If I say you are having this XYZ disease because of this particular, sorry, XYZ symptom because of this disease, then in that case, if that is the only uh, disease which affects for a particular symptom, then we say, given this disease, it's sufficient to claim he is having this symptom. Or given this XYZ symptom, it's sufficient to interpret that he is having a PQR disease, something like that. So this is meaning of necessary and sufficient. So now let us go ahead and quickly um, try to understand some more other properties or some more other derived connectives that is called as, see, these are the primitive operation. Primitive operation means what? These are the fundamental operation, negation and or single implication, bidirectional implication, but there are certain derived operations. We call it as a derived connectives. So next, derived connective that you already learned in your digital logic design, that is NAND. So what is NAND? Anyone can tell me now? What is NAND basically? NAND can be shown by vertical arrow. Now I am not able to draw this arrow here. I will use paint. So you may say NAND operation is like this, P NAND Q. This is the logical symbol. So can anybody tell me now what is NAND operation? Yeah, anyone can unmute and tell me. Yeah, can anybody tell me what is NAND operation? Shravani, can you unmute and tell me what is NAND operation? I am sure you have learned in your digital logic design. Yeah, am I audible or not? Yeah, Hussein, tell me what is NAND operation? Hussein, unmute yourself.
Yes, sir.
Yeah, tell me what is NAND operation?
Sir, if any one is false, then the output is true.
Basically, NAND is some derived operation. It is derived from which fundamental operation? That is what I want to know. NAND is
Not
equal to
an
what?
and.
Not in any.
Not
An
first
and.
AND operation and then not. Correct. Very good. First you need to perform AND operation and then negation of that. So basically this is derived operator. So I'm just writing here negation of and these are the, this is the way you are operating that. We need to do the AND. Uh, Okay, so you need to do first AND operation. True and true is true. True and false is false. False and false is false. False and true is false. And then you need to do negation of that. So it will become false. This will become true. This will become true. This will become true. That's it. This is already you have done in your digital logic design. Let us go ahead. Your next derived operation, that is NOR, in line with this. So it is negation of OR, and it is basically denoted by the logical symbol for NOR operation is this P NOR Q. Okay, I'm not able to draw in Excel, that's why I'm writing. Okay, sorry, in between I'm getting some interruption. So, negation of OR, basically this is NOR, and you are just performing OR operation. True and true is true, and its negation, that is false. True and F is true, its negation is false. False and false is false, or false is false, and its negation is true. False or true is true, its negation is false. That's it. Done. So in terms of symbolically also, 1 minute. This is P and Q. This is basically equal to what? Not of P and Q. This is fundamental operation. This is derived operation. This derived operation is equal to this. This derived operation is equal to not of going ahead. There is another derived operator that is called exclusive OR. Can anybody tell me what is exclusive OR? Yeah, Chetan, can you tell me what is exclusive OR?
Yes, sir.
What is exclusive OR? You have already learned in digital logic, that's why I'm asking. What is exclusive OR? Yes, Chetan, continue.
Sir, if we
This is
give
symbolically,
uh,
this is symbolically shown like P exclusive or Q. And normal OR is P, this is inclusive OR. This is called as, this is inclusive OR, and this is exclusive OR notation. And now you continue, Chetan.
yes, sir.
Yes, Chetan.
Sir, if we give
Yeah.
input both input as a zero, then we get
Hmm.
output as a zero.
Hmm.
And if we give one input as a
Hmm.
zero and other input as a one, then we get output as
Hmm.
a one. If we give one input as a one and another input as a
Hmm.
zero, then we
Hmm.
get output as a one.
So
If we
let
give
me know,
both input as a
Chetan.
one, yes sir.
हाँ 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 you continue, continue.
If we give both input as a one, then we get output as a zero. So मुझे टेबल
Correct.
पाया.
Correct, correct. Very good. Now you can mute. So what is this that you are learning in digital logic design? Same thing is, I'm just repeating here. What is exclusive OR? It is basically, assume we are having two proposition P and Q. The exclusive OR of P and Q is denoted by this symbol. What is its interpretation? It is this exclusive OR is true when exactly one of the proposition is true. Inclusive OR means what? Either one or see, at least one proposition needs to be true. That is inclusive OR. Here, at most one means this is a binary operator. At least and at most one proposition need to be true. Then we say the result of this is true. At least and at most. At least also one, at most also one. Proposition need to be true. Then we say this exclusive OR is true. What about here? At least one true means what? Either this is true and this is true and this is false. So here you can say at least one and at most one. I can just come back to this and tell you. At least one, yes, it is there, but at most one is there. No, there are two truths. So therefore, it is not satisfying the condition of exclusive or at least and at most one only. One proposition need to be true. Therefore, it is false. At least one, at most one proposition need to be true. Satisfied? Yes. At least one, no. Therefore, false. At least one, yes. At most one, yes. Therefore, it is true. That's it. This is exclusive OR. So, these are all derived operators. Basically, your fundamental operators are negation and or single implication, double implication. Rest are derived operators. This can be derived from some other operator. This is fundamental operator. Okay. So now let us go ahead and try to understand uh, associativity property, whether it is satisfying or not. So let's do the conclusion that uh, if we take, okay, I will leave this as an exercise in one tutorial. I will not discuss, but one point I need to discuss here that we need to understand P implies Q. It is here. Yeah, yeah, here it is. P implies Q. So there are certain logical equivalents. If you want to again convert into some other primitive operation, so P implies Q is equivalent to not of P or Q. I think this also you have learned in your digital logic design. So not of P or Q. If you take not of P, that is FFTT, or Q, F or T is tree, F or F is F, sorry, this is now not of P, that is T or F is true, not of F that is true, true or true is true. So you just compare this column with this column. I'm talking about P implies Q. So you can see with respect to the truth table, for all possible combination of this propositional variable, you are getting the same truth values. So therefore, P implies Q is equivalent to not of P, sorry, P implies Q is equivalent to not of P. This is equivalent. There is equivalent. There is a difference between this symbol with equal. Equal means left hand side is equal to right hand side. Both are same. Equivalent means what? They are similar. The left hand side expression is similar to the right hand side expression. So similar is nothing but equivalent. There is a difference between equal and equivalent. So don't draw this double line. It should be equivalent symbol. So not of P or Q. This is the transformation of P implies Q in terms of OR. That's it. So what point I need to highlight here? There are three things which you need to learn. One, I'm talking with respect to P implies Q now. So the first thing is converse. Now what is converse of P implies Q? That is what we need to understand. So given P implies Q, the converse is always Q implies P. Number two, the contrapositive is always equal to, means what is the contrapositive of P implies Q is not of P implies not of okay. Uh, what I'm discussing, not of P implies this is contrapositive. Not of P, no, not of Q. That consequent we are giving. Not of Q implies not of P. I will just discuss with an example. I'm just writing the form of converse, contrapositive, and inverse of given implication. So inverse is equal to, inverse is not of P plus not of Q. That's it. Okay, so given P, given single implication P implies Q, what is the converse of this? That is Q implies P. What is the contrapositive of this? That is not of Q implies not of P. And what is the inverse of this? That is not of P implies not of Q. Let's take one example to understand this. Let us assume P is, it rains, and Q is, let us say, the crops will grow. Okay, so we want, see, P and Q is just a propositional variable. What is exact proposition? It rains. This is represented by propositional variable P. The crops will grow. It is represented by propositional variable Q. Now, we need to understand what is the P implies Q. What is P implies Q? What is the statement? I need one volunteer to tell me. So let Ishita unmute yourself. Ishita Raut. Ishita Raut, please unmute. Janvi Taide, unmute yourself.
Yes, sir.
Yeah. So P implies Q. This is a propositional statement in symbolic way. I want a transformation of this into sentence. What is P? It rains. What is Q? The crops will grow. So the P implies Q in statement. Can you tell me what is that statement?
If it rains, then the crops will grow.
Very good. Then the crops will grow. Very good. Now I want the converse of this. What is the converse? Q implies P. So what is the statement?
If the crops will grow, then it
Hmm.
rains.
If the crops will grow, then there has been rain, whatever.
Yeah,
It rains or there has been rain, whatever. It
yeah.
rains. Okay. Okay. Next is contrapositive. Tell me now, what is the contrapositive?
If the crops do not grow,
If the crops
uh,
do not grow,
it does not
hmm,
rain.
then
It does not rain.
there is no rain. That it does
Okay,
not
yeah,
rain. There is no rain. Yeah,
yeah.
correct. And what is the inverse?
If it does not rain, the crops will not grow.
If it does not rain, then the crops
Will
will
not
not
grow.
grow. Very good. Will not grow. So you can mute now. Good. Appreciate. So now what I request to everyone, kindly draw truth table for this. Means I want to know the truth table values. 1 minute. I will just draw here. This is P implies Q. Okay. So you need to have here converse, contrapositive. I'm just writing in word. You write in terms of uh, notation. And the next is inverse. So kindly complete this truth table now and let me know the answer. This we already discussed. So now complete this truth table. Converse of P implies Q, contrapositive of P implies Q, inverse of P implies Q. I want these values. You work out this. I'm giving you one or 2 minutes. All students kindly work on this because we need to draw some conclusion from this. So I will wait for 1 minute. Quickly do it, and we will complete. If anyone have finished, please let me know. What is the converse of first? Yeah, anyone finished? Let me know the converse. Mansi Chavan, unmute yourself.
Yes, sir.
So, what is the converse? What is the truth value here for this truth? If P is
True.
true and Q is true, Q implies P, true. Then what is this?
Second, true.
Complete?
Sir, am I audible now?
Yes, yes. Yes,
Okay.
yes. Continue.
True.
Next,
True.
next.
Uh, First was true. Uh, Last one false.
Last one false.
Yes.
Is it the same? Any other answer from any other student? Is there any other answer? Okay, very good. Now let us go for contrapositive. Continue. Khushbu, continue now. Khushbu Bulwani, are you there, Khushbu? Ri- Ritika, unmute yourself. Ritika Dwivedi,
Yes, sir. Hello,
what is
sir.
the contra?
Sir, am I audible?
Yes, yes. Continue now. Contrapositive. Truth table.
Yes, sir.
Yeah, tell
Wait
me.
a while, sir. False. True.
Hmm.
Mm, True. Mm, True.
Next,
Wait. Yes, sir.
what is this truth value?
So wait second. So second will be false.
Okay.
Huh.
Third,
Huh.
third,
And this true.
true.
Yes.
Next,
And next one will be false.
false.
Yes, sir.
Okay, very good. You can move. Swati Utekar, unmute yourself.
Yes, sir.
Tell me the inverse.
True, 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 false.
Okay. So
Sir,
what is your conclusion from this?
hello, sir.
Yes.
In contrapositive, at last I got true.
Okay. So there is a deviation. Who was earlier? Swati, you
Yes,
were.
sir. It will be true.
Ah, it is true. Okay. Okay. So now what is the observation? Observe column number. Like if I denote this as column number 1, 2, 3, 4, 5, 6. What is the conclusion from this? What is the observation that you are having? What you conclude from this? Yeah, Swati, can you answer what you conclude from this?
That the statements are dependent on each other.
Statements are dependent on each other means what? You can conclude this that by looking to column number 4 and column number 6.
So they both are
What?
same, converse
It is
and
not same. Again, you are saying same. What is this?
Symmetric.
Sir, equivalent.
Equivalent. Equivalent.
okay,
So
sorry, sir.
converse is nothing to say. Sorry, we are learning here. Converse is always equivalent to inverse. Converse is always equivalent to inverse. Uh, is it true whatever we have written here? No, 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 no. True, true. P implies Q we are writing. So this is true. True, false, false. False, false, true. Now, what is another conclusion from this? Implication is always equivalent to contrapositive. So these are the two important conclusions that we have drawn from these logical connectives that we have discussed in today's session. So remember, converse is always equivalent to inverse. That means converse, that is Q implies P, is equivalent to not of P implies not of Q. So Q implies P is equivalent to not of P implies not of Q. Similarly, P implies Q is equivalent to not of Q implies not of P. Not of Q implies not of P. This is the primary implication given to you. Its contrapositive is what? Not of Q implies not of P. Its inverse is what? Okay, first of all, its converse is what? Q implies P. That is, consequence becomes antecedent, antecedent becomes consequence. That is the converse. So, if I take its contrapositive, it will be what? Not of P and not of Q. That is what exactly we are writing here. No? So, P implies Q. Its contrapositive is what? Not of Q implies not of P. We are not able to view this properly. Here you can see not of Q implies not of P. If you take its converse, now this is also implication, no, converse, and you take its contrapositive. Contrapositive of converse contrapositive of this. This is if you treat as a implication, it's contrapositive is not of P implies not of Q. But basically this is inverse. Sorry, this is converse of this. So for this, we say implication is equivalent to contrapositive, and converse is equivalent to inverse. Converse is equivalent to inverse. Now this converse and inverse, we are talking with respect to this P implies Q. So hope this is clear. Please respond in the chat box. Is it clear or not? Any questions? Please let me know in the chat box. Quickly respond so that I will understand whether this is clear or not. Okay. So in the next, before concluding this session, I would like to inform you that whatever statements we will receive, just like we have written one statement here, if it rains, then the crops will grow. So we need to transform this, we need to decompose this into some propositional variable, convert this sentence into propositional variables and then propositional statement. And then we need to check if we need to check the equivalence of two statements, if they do have the same propositional variable, you can have a construction of the truth table. And with the help of construction of truth table, you can verify what are the truth values, whatever maybe your statement here. If it is same, then we say both statements are equivalent to each other. If they are not same, they are not equivalent. And one more concept you must have studied in your digital logic design. If all the truth values are like this in that column, what is this called? Anybody can tell me what is this called?
Tautology.
Tautology. Correct. If all the truth values are true, no matter what are the possible combinations of your propositional variables, it will remain universally true. So it is tautology. And similarly, there is a contradiction. When everything is false, it is said contradiction. We will continue this discussion in the next session. We'll stop here. Please post your attendance in the chat box.